So we'll start our session for today. So today what I will be teaching you is the basics of LangGraph, how to use LangGraph, what are the different APIs in LangGraph, how to create graphs. In this session we will not be learning about the AI part, but how to build the agent part, that is how to create flows, how to define tools, how to define the execution flow in LangGraph. So we'll be learning the basics of LangGraph first, how to define state and everything else. So for using LangGraph, for first I've just initialized our chat OpenAI from LangChain OpenAI to get to see if the my Gemini model is working or not. So this is just first initialization. Then for the actual LangGraph, so LangGraph provides you something called as state graph, uh, in which you can define your agentic flow. So I'll be importing that first. It's in langgraph.graph. It's state graph, and start and end is nothing but to define the begin and the end of our flow. Now, in order to define the state of the agent, we have to define the state using a typed dictionary or a pydantic based model. So today I will be using typed dictionary because it is recommended in the LangGraph documentation. From So I have to import the type dict from typing library. Type dict. Now I will just define a simple state here, which will contain messages of the agent. You can give it any name. I will define the messages. Now the messages will be a list. In type dict, we have to give proper type hints of the data type. So the messages will be a list, and of what it will be a list, we can define it as a base message from LangChain, or you can just keep it as list to keep it simple. For now, I will just keep it as a list. Then I will define the agent. So I will just show you how to build a simple chat bot with memory using LangGraph. So it will give a good baseline about how messages are updated, how state is updated, and how to start and end the agent call. So in state graph, I have to give the agent state as a parameter. Then I have to define the nodes. The nodes will be basically the processing units of the agent. And you can define those nodes using basic Python functions. So I'll be first defining the initializing the LLM, that is get the system messages, initialize the system messages. So init LLM, and it will compulsory take the state as the parameter. Without passing the state as a parameter, it won't work. So I will define the system prompt here, a basic system prompt. You are an helpful chatbot with strong memory and recall capabilities. Now we have to pass it to the messages. So I will be using the langchain message data type to make it easier. From langchain core dot messages, import human message, system message. I'll be defining it as system message, content as system prompt. Then in order to update the messages in the state, we have to give it as a return as a dictionary. So I'll be returning return messages, and the data type of the messages is a list. So I am defining the message as a list here, and I will passing it here. So that will update the state of the agent. Now I will actually take the input from the user and get the output. Def call model. So now I will just take an input from the user message, a standard Python library for taking an input from the user. Then I'll be adding it to the messages. I will first retrieve the messages from the state. Then I will append the user message to the state. Human message, user message. Then I will pass the message to the LLM. LLM.invoke messages. Then I will append the response of the LLM into the messages, and then I will return the messages in a dictionary. This is basic how to define the nodes. Now I will add those nodes into our graph. You have to just call agent.add node, and you can either directly give it the name of the node, or you can just pass the function. It will take the function name as the name of the node, but it's better to pass the your custom name for that node. Then I will add the edge, that is set the entry point using start, which we imported before. And also define the exit point. And from init LLM, it will go to call model. I will define the flow for how the message will flow through our agent. And I will define the end point of the agent. Now we'll compile the agent. I guess it's better to name this as a graph. Compile doesn't take any arguments, and then I will just print the agent so that we can see the graph of how the flow works. So you can see it starts from start, it goes to init LLM, and then from init LLM it goes to call model, and then it ends the call. So how to invoke the agent? So I will be using the runnable config using .invoke. So agent .invoke, and I will pass the messages as an empty list because it will automatically define the system message for it in our init LLM node. So I don't need to give it a system message before. Now I can just run this and check if it works. So I can see here it gives me a query. So I'll just say hi, and you can see the response, the output of the agent will be the state that we passed in the graph. So the output will be of type agent state. So you can see in the messages where system message, human message, and the AI message that it gave us. So now you can see that we have made a chatbot, but you can see that it doesn't make any calls. It only runs at single times. It is not very useful for us. So how can we use loops in our nodes in our agent graph? So for that we have to do something known as conditional edges. And conditional edge, you can define conditional edge using the same format as how you define the node, but instead of returning the agent state, you have to return the name of the next node that it will go through. So should continue, and I will ask if do you want to continue. So if the user returns yes, then I will return it should go to call model again. So you have to just return the name of the node, else it will end. So I will just return end. Then how it should go, from start it will go to init LLM, then call model, and from call model it will go to the conditional edge and then try to go to call model or end. So I can remove this call model edge and instead add a conditional edge here, graph dot add conditional edges. Then I will define which source. So it will be calling from call model. After call model it will call this conditional edge, then pass the function that is should continue. And sometimes what you can't get the output of the graph because the draw mermaid PNG that we get the image, it uses the online API. If the service is down, you won't get the result, but our agent compiles without any error. So now I will check again. I will hi. Then it asks me, do you want to continue? I will say no. Okay, sorry. I should have given yes. My mistake. Then yes. Next message. My name is Ronak. Internet is not working, I guess. Gemini. I'll try running the entire notebook again. I will check if it's actually recalling my memory. What's my name? Yes, so it's working now. To continue, no. I will exit from it. I will check the responses. So I gave it what's my name. It can recall my name. So the memory is working. So did you get the basic idea of how LangGraph how LangGraph works? You can respond in your messages or uh, unmute yourself and speak. Swayam, do you have any doubts or do I need to explain again the basic law of LangGraph? Any point you didn't understand?
Not now. I think when I implement it, like I will be more clear with it.
Okay, so I will be sharing the GitHub repository for this code after the session. So you can try running the code and see, making some of your own tweaks and check if it's working. Okay, so how we appended the messages here. You can see that we just took the messages from the state and then appended our message here. But this is inefficient. It is not the recommended method by LangGraph. So what LangGraph recommends is we have to use something known as annotated. So what is annotated? So annotated is a gives you metadata about the data type. So from messages, we have to give the function to use to how to add the two variables. So in simple words, you can understand it as I will demonstrate, then you will understand it better. So annotated. So annotated, then going to be a list. Now what is operator.add? So operator.add is nothing but a function defined. So you can see it's a simple function. It takes A and B as an input. So how add works? So in this it is defined how to add two data types, that is numbers or lists or anything. So if I give it an input as 1 comma to a list and then just give it a number 3, it will give an error. It requires both A and B to be of same data type. So you can see now it works. So in this way, what operator.add does, it tells LangGraph how to process your messages. It works on known as a reducer mechanism in LangGraph. So you don't need to get into too detail about it, but just understand that annotated provides the LangGraph metadata about how to operate on that data type. So when we return the messages, it will call operator.add on the messages and the what we return. So in this way they can be added together. So now it's okay here, but here we don't need to call our state. We can just define messages as our empty list, then append a human message to it and LLM call and then return messages. In order to, I will also print the response so that we can understand it's actually working. Print response.content. System response. still not working, drawing the agent. So now we'll call again, and you can see it works the same. I will just give it some 2 or 3 general response questions, and then I will ask my name again. I mistakenly type no here every time, so it gets exit. We'll check if it gave the response. So did you understand the annotated and operator dot add, why it's used? You can see that it appended the messages correctly, even without first getting the messages and then appending to it. Using operator dot add and annotated, we successfully managed to do what was before, but in a more cleaner way and the recommended way for LangGraph. So you won't face any problem if you just use calling messages from the state and then appending to it. But if you are doing parallel calls to multiple LLMs, which I will show now, there if you use just messages, get messages from the state and then append to it, it won't work as good. It will append the messages multiple times. I will demonstrate to you, and there it's actually useful to use annotated. So I will demonstrate it now how it makes a difference and how to do parallel calling. I'll do new notebook. So now I will just use list, and as I told you, you can also define as a base message because all the messages like system message, human message, AI message are of a base message type. So you can use that also. It's not necessary, but it just helps you understand what data type is used. It helps enforce strict data types. So now I will just create, we'll make a parallel call to three LLMs. First LLM will use to create a poem, second LLM for a story, and third LLM for a joke. So I will give it a topic, which will be a user input, then a poem, then joke, and a story. Now I will define three calls. Generate joke, so I will just make a simple call to LLM, not defining system message because this is just for demonstration purpose. Tell me a joke about. So you can see we can also use chat templates here, but using f strings is better and simpler. So I use f strings here. You can also use chat template, but they just make our task unnecessarily complex. And I will now return the joke. Similarly, I will tell it to generate a poem. Gem- Copilot did the work for me. And now I will define our agent. I will add those to it. Generate, I guess just poem. Generate poem. Generate joke and generate story. Now I will define the edge. Now in order to define parallel calls in LangGraph, you can just do a simple way, which is getting the source node and then defining the multiple destination nodes. It's just as easy as that. So from start node, it will go to poem, joke, and story. And LangGraph automatically handles the parallel calling under the hood. There is also another method which I told you before, which can be used to get this agent graph using a get graph and draw ASCII. It requires something known as grandal, so I have to install that first. Also have to install it for my system. So you can see here it just printed in ASCII. So if your mermaid graph is not working, the API is not working, then you can just use the draw ASCII method. You just have to install pip install grandals package. For that, you can see from start it goes to joke, poem, and story all in the same time. That is parallel calling. Now I can just invoke it, and I will just give it a topic, a simple topic on monsoon season, I guess. Let's see what it gave us. So you can see that it successfully generated the poem, joke, and story. So this is the basic for parallel calling. Now here you can see some error. There is argument of, it's not an error but warning that argument of type dictionary cannot be assigned to parameter input. So the the reason we are getting an error here is because we define the state here, agent state, and in that we define poem, joke, and story as string. So it expects us to give it a poem, story, or joke even if it's blank. So in order to avoid this error, because the poem, story, and joke will all be generated by the agent, they are not given by user. So it doesn't look clean to pass empty poem, story, and joke. So instead of that, what you can do is, here you have to tell the agent state that this is generated later. So it's not at initialized, but it will be generated by the agent later. So for that, there is something known as not required. Not required. So we have to add not required type to it. Now if you see, it doesn't give us the warning. So this is the response from our LLM. Now, did you understand parallel calling? How to do parallel calling? Because parallel calling is simple. You just have to do multiple calls from the same source node. So it's not difficult.
Is it not mandatory to return the same state from each of the functions?
Like uh,
Uh,
same state.
like uh, in a generate joke, you only return joke, right?
Yes.
A dictionary with a joke key. Like we don't have to return the same state like the agent state everywhere.
No, because in line graph, what it updates is, it updates only the key value pairs that you return. So if I
Okay,
give joke, poem, story, it will update all of that in a single return call. But if I only provided a joke, it will only update the joke. So it depends on you which values in the state you have to update. So if you only want to update particularly one key, then you have to only pass that key only. You don't need to pass everything else.
okay,
And you cannot do something like you can't do like state joke and then you can't do this and then return the state. That doesn't work. Yeah, only works by returning the dictionary, and within the dictionary you have to return the key to update. So this is the standard of LangGraph. Now what I will do is I will show you how annotated an operator, why it's useful. So here we only generated one joke. So what about you want four jokes, and out of those four jokes you have to decide which is the better joke. So for that I will define jokes as a list of string and the final joke, and this will be from the not required set. We'll use another agent. It will generate jokes. It will generate four jokes. So I will use the same prompt as here. So now I will be returning multiple jokes here, because what I'm trying to do is I will uh, parallelly call generate jokes 4 times. So what the standard way was before we used to do was jokes equals to, you have to first get the jokes from the state, then append the jokes to it, append our added joke to it, then return the jokes. Now this was our before, how we used to do. Now I'll show you why this creates a problem. So I will be creating four jokes. And I will do the start parallel calling. So you can see it at the start, it calls uh, generate joke 4 times parallelly. Now I can check. Now we'll see what the response is. Why didn't it update? So you can see it gave us an error. It told us to use annotated. So in these situations, we have to use, for these situations, we must use annotated. So now you can see how, if we use annotated, how it will work. We have to provide it a reducer function, which is operator.add. Then we don't need to return list, but we can just return the joke. Now you can see it's working. Now you will see that it generated the jokes, and you can see the length of the jokes. So it generated 4 jokes perfectly. Now sometimes if you don't use annotated, it can do multiple calls and uh, multiple the same message may get appended again and again in the previous step. This time it directly gave us an error, but sometimes it will work but not give us the accurate response. So always we have to use annotated if we are going to use list in the agent state. So is everybody clear about how do parallel calls and why annotated is useful? So now the next step is, you may notice that in the previous example where we called should continue state, it just returns the next node to call. But what if you have to pass the updated state to a node? That is, if the conditional edge is going to 2 or 3 nodes, and out of those 2 or 3 nodes, the first node should have a different state, second node for a different state, or third node a different state. So how to give those different states to different nodes? Because just using conditional edge, that's not possible. For that we have something known as update state. We have to update the state. For that we have to use a different method. There is known as a command. So using command, we can send the updated state to the next node. So for that I will demonstrate a simple example. In that I will define as a topic. So what it will do is it will take the input, then check what kind of input it is, and based on that input it will generate a different uh, output. And I will define here type. So it will generate whether either a joke, a poem, or a story based on the input we give. So it either be a joke, poem, or a story. So literal is used to define that it will only take these three options. It won't take any other option if you give it to it. And then I will just define the response. So I can do the method that we did before, like define three functions for each for a joke, poem, and story. But that will be a bit uh, unnecessary. Instead of that, what I can do is just define the system message and take which system message to use based on the input, and then I can just send the updated state to the function. So here I can say I'll get the task. This response will be a not required type. So instead of directly returning, I will use the command. I will return the command, and in command, you can see there is a go to option. The go to means to which node to go. So here I will define generate response node, which I'll be creating later, and update. Update will be basically which what state you want to update. So here I can define the prompt that I generated here. So you can see if we try to access the prompt type, it gives us a warning or an error because we defined it as not required. So the interpreter confuses it as it can be none or it can be string. So we have to define it using get. So then we can just return our response. Graph.add node. And then I will define the conditional edge here. which will be going from init LLM. So init LLM is our um, initial from start. Here we have to return it as a command. You have to statically define what output it will give. Agent.getGraph. It's not working. I'll check the document docs again. If you get any problem or doubts, you can always go to the docs. So this is a graph API that we are using. The command. So it just add edge. It's not conditional edge. Also have to add it as a node.
You added it as a edge.
You have to add it both as an edge and a node also. Oh, sorry. Should be node. Okay, so now you can see that we get the correct output. Now we'll check the response. I didn't get that topic. Sorry, it should be F string here. Sometimes Gemini refuses to work. You can just restart and run it again. So now it works properly. So you can see it gave us the response. So this is how you can use a command. Using command, you can update the state if you want to give it to a different edge. Because using a conditional edge, you can't give it the updated state to the next node. But using command, you can give it a updated state to each different node that you want. So you do understand the command and any questions or doubts about it. Okay, so more use cases of command. So I guess better world applications for command would be using in a previous example where we did I will be using this to give you a demo of command, how you can reduce one function. So here what we can do is this is a conditional edge. So we can first get the response from here, should continue, and instead of that we can just take a normal response, enter your query and use wait to exit. What we can do here, okay, so what we can do here is it will either send it to end or it will send it to call model, but for call model it will update the state and pass it to call model. So we can get messages, human message. If the user input is not quit, then you can take this, and then we have to update the state for messages, right? So then here we'll use command. Then we'll pass the update to here. Then instead of asking the response, user response in call model, we can directly take it from here. We'll get messages from state. Then if the query is quick, it will go to end, but you can't directly give it end, so we have to pass it through command. We go to end. So then we have to define the return state of it, which will be command call model, and the end that we print here, it's nothing but you can check it's underscore underscore end. So we have to pass it here. Because string literal and command takes a string as input, so you can't directly pass end to it. Uh, First will be the init LLM, the call model, and should continue. Then from start to init LLM, then init LLM to it should go to should continue. And then we can compile it. So you can see it first goes to init LLM, then should continue. Then if it says it should go to call model or end. Now you can see that after call model it directly goes to end, but we don't want it. What we want is after call model it should again go to should continue. So then we have to define the edge here like that. From from call model to should continue, because we don't want to end the agent in one single call. So now you will see from call model again, after calling the model it goes to should continue again. Now as the messages is of later, it will be written later, so we can just use not required so that we don't get an error here. You can just pass an empty dictionary. Now you can see here it gives me a say hi. It's working. Then if I uh, type quit, it should exit. Now I can check the response. So you can see the messages, it successfully appended the messages properly. So directly type quit, it will exit from it. Are you clear about command or need more examples? It's you will not like it's not getting a exact view of command. Don't worry, because this is a simple demonstration example where we will actually coding our Linux script generator agent. There you will get a better view of how command and send API is used. It will be useful in our complex flows. This is now just for a demonstration purpose. So you should just get an idea of how to use it. So now, do you have any idea of about what agent we can make? Like a simple agent we can try in this session, or if it's like a bit complex, I can do it in the next session. Like uh, when you're coding or when you're doing in your workflow, what we can automate, like something that always requires human intervention, that kind of task we can try to automate here with an agent. We can try to build that agent. So any idea you have got? Uh, so it doesn't matter if you don't get the idea immediately. You can message me in WhatsApp later if you have any ideas, because what I'm more focused on is if the agent can solve your actual problems in workflow, then it will be useful. Because otherwise, I will just be doing like a demonstration, demo agents, which are like not very useful in application purposes. So, do you have any workflow that we can automate? If you get any good idea, a simple idea that you can share on WhatsApp later also.
I have an idea, but uh, I don't know it is simple or complex. Can I share it now
Okay,
or
share.
on the WhatsApp?
If it's like too complex, we can try to strip some of the parts down and make a simple agent out of it. So let's hear your idea.
I'm thinking about building an agent in which we use the WhatsApp integration, where the user message me about the uh, documents or the experiments he wants from me, and automatically when he gives the subject and the experiment number from my storage, it will be shared to him or her.
Okay, so if someone sends you an like send me experiment 3 of NLP deep learning, then it should automatically fetch that experiment in your storage and send it to him directly, right?
Yes, yes.
So for that, what we can do is first we need a proper integration with WhatsApp, so that our like using Python we can communicate with WhatsApp. Then we need to interact with our storage. So the interacting with the storage is easy, but like WhatsApp, I don't know. I will like see if WhatsApp provides a free API or anything that we can directly use in our uh, Python, so that we can connect to it. Like if we get a message and then it will start our agent. Uh, I will check that, because I know there are paid APIs for to do that, to access WhatsApp information, but like free, I don't know. I will check about free APIs. But if you don't get a free API, I will also in the next session I will try to show it using the paid API. So what we can do is a simple idea. We can create a cloud server, a simple cloud server. On that cloud server, whatever experiments you do, you can directly send it to the cloud server. It will automatically organize the sent files. Then when there will be a central a same number, like a bot, we will create a WhatsApp bot, and then if anyone wants the output of that, the person can message the bot the experiment number, the and the subject name, and then based on the input query, it will automatically send the document to the user. So does this sound okay? Like it's not exactly like using your storage, but cloud, because otherwise you have to do like something for Android, and I don't have experience with Android. But for cloud, we can easily do it, as it's much easier to do it on cloud. So is that okay? Like, yeah, we can. Yes, Telegram is also a good alternative. So I haven't done about Telegram. So Sumit, like Telegram provides a free API to interact with Python, like interact Telegram messages with Python. I haven't done used Telegram bots or anything like created them.
I guess there are free Telegram toolkits available. Like I have seen somewhere online.
Like we can directly interact with our local Python code.
LangChain Telegram message.
Is there LangChain Telegram? Let's check.
It's in document loader section. Yes, it offers file sharing. It is mentioned here.
But like it doesn't give you like if someone sends a message, then it should be like a event stream, like I send a message to that bot, and then that bot will send the event to the cloud server, and then it will act on it. This is like you can get the chat of a certain like for the chat URL, you can get all the chat for that bot. So
We can try with anytime integrations. I guess we can. That's the one thing we can use. Have you tried anytime?
yes, I've tried N10, but like N10 only provides like 30 days of free URL, free usage, and
Oh,
for you can also deploy N8N locally, but when deployed locally, there are some issues with authentication. Like we have to deploy our own authentication servers for that. Like if we want to interact with the Google services, then we have to use uh, connect to the Google Cloud Console using that callback URL and all. So for that, we have to deploy our own server for that authentication. So it becomes complex. It's not easy to set up for locally, and for like online web-based platform, it's free for 30 days only. So it's good for the local version, is good for testing your basic documents and loading, but if you want to connect to real world applications, it's not possible using the locally. We have to use the web-based version only. So I was trying to connect with my Gmail and Google Docs, and it was like the authentication was not working. I tried deploying it on server as well, but didn't work properly.
we can manually create some Telegram bot and then set some sort of trigger on it whenever someone message on it. Like I haven't created a Telegram bot myself, but I think Telegram provides you to create allows you to create bots.
Yes, we can create Telegram bots. I did a Telegram bot, but it was like using the tools in the Telegram itself. I didn't like create my custom Python code for that. So I don't know if it's possible with Python, but I will check after this session. 2 3 days I will check how it to connect with Telegram events, get a new response, and then act on it. It should be possible. but I don't know if it's free or paid. I guess like WhatsApp provides it, so Telegram should also provide it. We have to only check if it's free or not.
Or we can use a simple email service like the when whoever person wants some sort of experiments or some write-ups, he or she will send his or her email along with whatever she requires.
Okay. So yes, yeah, that will be easy, much easier. Yeah, so in the next session, we will do using email, but if it's possible using if there is a free Telegram API, then I will do Telegram one. If it's not, then I will use the email version. Okay, is that so? We'll try to create our own working agent. For that, we will use local storage only. But if you want to deploy it for your own class, then you can if you want you can buy the cloud storage and properly deploy it, but for session we will use local storage only. Okay, yeah, if you get any information about Telegram or WhatsApp, then you can inform me. Yeah, it was a good idea for mini project as well as for major project also. It was very good, like we can integrate multiple services by WhatsApp, Telegram, Gmail, and create a centralized server that can take the information from all that and coordinate everything. So it's a good idea. Uh, so Swayam, if you want to do it for like next semester, integrating multiple services, making it more intelligent, then you can try for your next semester mini project. It's a good idea. So any doubts about like LangGraph? Like if you have any doubts, or else we can end the session, because this was just like in order to give you a basic idea about LangGraph, not doing actual agent work. So I will after this session I will share this repository. So any doubts? Like reading on docs, uh, there is no like shortcut for that. I went through LangGraph documentation for like a week, entire week. I went through everything. Now I know what is available where, but you can use like the search to do, or you can just directly type your query on Google and use the docs for like LangGraph command docs. So you can use that. But if you want to know what's in the entire doc, there is no other way than directly reading through the entire doc. LangChain example. Like you meant like the source code for the LangChain functions and the modules, or the like examples that they've provided in the cookbook? Like what exactly do you meant by
I meant the examples that they have provided in the documentation. They're outdated.
uh, like LangChain that recently it's going on a new documentation, like new docs. These are the new docs. LangChain will be updated in the next month, like October. So for for that there is a new documentation available, and also the langchain library will also change a little bit. So now the latest docs, these docs like they are better, they are much properly organized. You can see in the left side it gives you proper overview of what you want, like if agents, morals, and long-term memory. Like if you want like how to pass image inputs or audio input, then you can go to messages, and here you will get the multi-model. So here it gives you an example of how to send image, how to send base64 image data, or PDF document. Directly you can upload your PDF document, or audio input, or a video input. So these even the latest docs that are updated of LangChain are very organized and give much more working code rather than the old ones. The old ones, they were not properly organized. Like when I was starting with LangChain and LangGraph, I thought that it was very outdated. The docs are not good. So I didn't understand LangChain properly. Only after like reading through all the documentation for over a week, I got proper knowledge of LangChain. So
The chat prop templates syntax is also very outdated. Like they don't even work properly.
no, don't use chat templates. Like I said, just use f strings in Python. Like it's not useful at all. It doesn't make any difference. You can just pass in f string, and it is way simpler and way better. Like, do you have a specific example where you explicitly need a chat template, or will that job be accomplished using f strings in Python?
No, that's just a fancy way to declare system messages. I think app strings will be sufficient.
Yeah, f strings do most of the job. Or if you want to use them later, you can use like format in Python. You know about like format, using format in Python.
Yes.
So you can use format also. Like first you can define the template, and then using run at like when you're actually calling it, you can use format and pass those variables directly instead of using f string. So thank you for joining today, and we will end our session. You can leave, or if you have any doubts, you can ask. So good night, and so about VS, about what do you want VS Code setup?
Uh, I'm not getting the virtual environment working properly with my VS Code.
Like even if you do like explicitly set it from here also, it doesn't work.
No, it doesn't work. Uh, I'm creating virtual environment using UV, right? UV automatically creates it for you.
Yes.
But when it when I go to select an interpreter path, it doesn't show path to my current virtual environment.
So you can like share your screen, and then we will check if how it works. So you can
Right.
share your screen and we'll see what exactly is happening.
Is my screen visible?
Yes.
Now I go to select here interpreter, right? It only shows my local interpreter, not the virtual and one.
Like, did you open VS Code from terminal or selected a folder from VS Code?
Uh, I opened it from the terminal.
It should directly load, right? You can close the VS Code and we can try again. Like, uh,
Hello.
can you close the VS Code and try from like we'll create a new environment using UV and check for that. So now we can close this, start a fresh new environment. Open the main.py file.
Yeah, now it's loading. Let's see if IntelliSense is working.
It's working now, right?
Let's, can you say me any other package that I might not have installed uh, on my system?
For langchain,
Which package should I install?
you can't directly use
Like,
pip, okay, with UV. If you want
okay,
to use
sorry.
if you want to use pip commands, you have to use UV pip.
Is that just list?
No, like you pip list will do. No, this is your like global environment. Like UV pip list, you have to do UV pip list because when you create a virtual environment using UV, it doesn't export pip as a command. Yeah, you have to call pip using UV. Only then it will work. Like in some documentations, you will have the guide like pip install the certain library. You can't directly use that command. You have to first add UV as a prefix and then use the pip install command. Because UV is like if you install a library using pip, then that library will not get installed in the pyproject.toml file. So uh, can you open the pyproject.toml file in the VS Code? So you can see it
Like
lists the dependencies. Like pyproject.
it is package.json
Yes,
for this code.
yes. So pyproject.toml, what it does, it lists all your dependencies. Then if you have any other metadata or everything, like which Python do you need, like Python 3.13, 3.10, or 11. So everything is managed by that pyproject.toml file. So before, what we used to do was requirements.txt. But the pyproject.toml is a more robust way of managing Python environments.
Is poetry same as UV or is it different?
The poetry is same as UV. They are both for managing Python environments. UV is like written in Rust and it's the latest one. Poetry is a bit older version. Conda is also there. They are older ones. Like with UV, you get fast speed. The main advantage of UV is that it can check the dependencies, conflicting dependencies, and automatically handle that, which was not possible with like Conda and um, poetry. Like if there's a conflicting dependencies, UV will throw you an error. But with Conda and all, they will directly install the latest library, and that will break your dependency, and the code will not run, may or may not run. So in this situation, UV is helpful, and it uses Rust under the hood. So
I never came across UV. The first time I saw UV was in your station.
like,
I thought this is a game changer. Then I thought this is a game changer.
once you start using UV, you can't go back to like poetry or Conda. Like I never used Conda. I always used to before. What I used to do was using Python dash mv and v, creating virtual environments using that way, and you creating requirements.txt file. Then I found out about UV, and now like always I use UV because UV gives
PP
you.
is too slow.
Yes, and UV gives you a reproducible environment. Like if you are using Windows or Linux or Mac, you just have to get the prior project.toml file, and then you can replicate your entire project, entire dependencies.
Do the host system also needs to have UV installed or we can directly install from PyProject or TOML file?
No, UV has to be installed, or you can also install UV as a Python tool, like pip install UV. You can also do that, but the recommended way is installing it as a separate tool. And it's not difficult, and the documentation gives multiple ways to install UV, so it's very easy. So anything else?
No, thank you.
Okay. Okay, so thank you and good night.
Good night.